4.4 kind of takes everything into actually watching, and we'll kind of play the launch video in just a minute. I got to find it because it's been acting up on me. So I don't know if we can find it, but we'll give it a shot. So it says using shadows to find heights using similar triangles. So how can you use similar triangles to estimate heights of tall objects? So for example, here you have the Statue of Liberty, okay, which is obviously much taller than a stick. But you can see like this side here and the height of the Statue of Liberty are similar sides, right, of a right triangle, right? The diagonal is similar to this side, right? The base is similar to this side. So you can kind of see how the corresponding angles, even though that it's much bigger, should be the same, right? Right? And how that all works. And again, so yeah, these triangles are similar, just one is much more bigger scale, obviously, than the other. So we're gonna do our first one together. Now it helps if you draw the picture. So it says a tree casts a shadow of a 25-foot shadow. So let's draw a tree. By the way, I was never much of an artist, so don't judge. Okay, so there's my tree. Beautiful, right? Okay, so if it casts a shadow, where is the shadow at? Is it up in the air? No, it's on the ground right here, right? So if it casts, this is 25 feet, right? So at the same time, a 6-foot stick casts a shadow of 4.5 feet. So here's a stick. Okay, so there's the ground. So there's whatever this is. Here's 4.5. This is a 6-foot. So that's something like that, right? Top of the stick to the edge of the shadow, right? How tall is the tree? So they want to basically know how high is this. So we don't necessarily need to worry about the diagonal here, right? How can we figure this out? I'll give you a hint. You might have learned something about it yesterday, Anthony Coleman. Well, okay, but how are we going to find this side then? Remember what we did yesterday? What did we do yesterday? Blake? You're on the right track. Think of this. Let me ask you this question: what sides are similar to the stick and the tree? Give me a set of similar sides. Okay, 25 and 4.5 is a similar set of sides, right? Give me the other one, Lily. 6 in the question mark. So, if we look at the tree, right? We don't know what that is, right? So we'll make it an X, a missing variable. What can I do to figure out what the stick's going to incorporate into this? Right? What side was equal to the question mark again? The 6, right? And this is 4.5. What does this look like? Our ratios method from yesterday? Yeah, starting to ring a bell a little bit. All right, so to go from 25 to 4.5, are we going bigger or smaller? Bigger. We're going bigger? Yeah, 4.5 is not bigger than 25, right? So how are we going to figure out the ratio from 25 to 4.5? Divide what? Yeah, if you take 25 and divide it by, and I think you get 5.5 repeating, right? If you divide 25 by 4.5, it's 5.55555. So to go to find x, what do I have to do over here? Sal? Multiply by 5.5 repeating. So take the 6 times and do 5 point, and they just put about a bunch of 5s afterwards and hit enter. What do you get? 33.3 repeating, and that should be in what unit of measurement? What unit of measurement are we talking about here? Feet. So what does this number represent? What question is it asking us? Anthony? Yeah, because it asks us how tall is the tree, so the tree is 33.3 feet tall. 33 and a third feet tall. All right? So I'm going to put you guys on a little task. I want you to do part B. Okay? Part B says Darius uses the shadow method to estimate the height of a flagpole. He finds that a 5-foot stick casts a shadow of a 4-foot shadow. At the same time, he finds the flagpole casts a 20-foot shadow. What is the height of the flagpole? So, again, if you're an artist, you're going to love this section because you get to draw. So, make the picture. That will help you. Okay? So, we'll give you a little bit of time, say about 5 minutes or so. Big hand on the 9, maybe 7 then. Let you try to work on this and see what you can come up with. All right? And I'll leave that example up there. We're going to pause. Okay. So, there's the shadows they cast. So how'd you set it up? Who wants to share? What answer did you get? Tell you here. Who wants to share their answer? Robert. 25. That is correct. 25 what? Feet. All right. So tell me how you did it.
I did x over 20.
Good. X over 20. Because again, you got the flagpole, right? And what side is X similar to on the stick? 5. So what was your second part of the proportion? 5 over 4. Because the X and the 5 are on the similar sides, and the 4.5 and the 20 are similar, right? So, to go from 20 to 4.5, what happens? If you took 20 and divided by 4.5.
I did 5 times 20 divided by 4. That's how I did it.
Oh, okay, you're cross multiplying. Yeah, you're kind of.
The shadow's only 4 foot. It's not 4 foot.
Oh, it's not 4.5? Oh, you're right, it is only 4 foot. So let's fix that. Okay, so from 20 to 5, what happens? We divide by 5. So to go this way, we have to multiply. What's 5 times 5? 25 feet. So that means our flagpole is 25 feet tall. Okay, let's go to the back side of this. So Greg and Zola, if his name was Gorg, that'd be really funny. Like a cheese, Gorgonzola. You ever hear that? Gorgonzola. Come on, that's a good joke. You guys didn't even laugh at it. So Greg and Zola are trying to find the height of their school building. Zola takes a picture of Greg standing next to the building. How might this picture help them determine the height of the building? Lily?
Could you say how many times drag makes up the building? How many times drag?
Yeah, we could use the ratio or even the scale factor to kind of help us, right? Compare Greg to the building, right? Because Greg's not the same height as the building, right? But to find the actual height, that can help us. So if we do our work down below here to part B, so if Greg is 5 feet tall, okay, so this is the actual, so here's Greg. Greg's skinny. Greg is 5 feet. Okay. And the building is 25 feet. So let me draw a building here. This is going to be pretty bad, so just humor me. Building is 25 feet. Okay? Now, there's something here to deal with the picture, right? The picture she took, the picture Zola took shows Greg as 1/4 inches tall. So we draw Greg again. How tall is he in the picture? Right, we can write it as 0.25 feet, right? Or inches, I mean, because he's tiny. Okay? So what we're going to have to figure out then is how tall should the building be in the picture? So if here's the building in the picture, I know, I'm Picasso. How are we going to figure that out?
The ratio method.
You like the ratio method? Okay, so let's circle our similar sides. What is similar to our missing side? 25 feet, right? And what is similar to Greg? Right, the 0.25. Now, we, so, okay. So how are we going to set this up as a ratio? Huh? X over 25? So you're going to use a similar side to the buildings? This? Okay. And? Alright, so you really didn't use the ratio method. What did you use? You used a scale factor method. Right? Because if we did the ratio, you have to have X over, right? But that's okay, because remember, we figured out, we can figure it out, it works both ways, right? So if you did it the ratio method, you would have this, right? Right? Still going to work, I hope. So, to go from 25 to 0.25, what do you get? So if you take 25 and divide it by 0.25, what do you get? It's 100. So you got to divide 25 by 100 to get 0.25. Well, this is where it's not. This doesn't work. But it works with the ratio method. Why do we get different answers here? That's kind of weird. All right, I'm going to get rid of the scale factor one, okay? Because for some reason it doesn't work. Because the picture can't be 500 feet tall. Why? Why can't the picture be 500 feet tall? Because the picture then's bigger than the actual building. Is that like possible?
I wrote it down, but then I got it to 1.25 feet.
For that?
Yeah.
For it, I guess I thought I didn't write it down because the same factor. I didn't
But if you set it up with a scale factor, oh, that's why. I bet you we put in the wrong. Because X. No, that's not right. Yeah, because these are the same sides, right? These are the corresponding sides, but this is scale factor. So to go from 25 to 5, you have to divide by 5, right? So to go this way, I have to multiply by 5. Well, 0.025 times 5 is 1.25. So the building in the picture should be 1.25 inches, which is much, much bigger than good old Greg. That's what happened. We had this part flip-flopped the wrong way. So you see how that can throw your answer off? 5 to 500 or 1.25 to 500. That's a different. That's a big difference, right? All right. So you got some class time to do your homework. That's a good thing, right? So let me go to here. I'm just going to write the assignment in here. Page 95. 19 to 24.